Just want to. Hello, everyone. My name is Emmanuel, and I am a software engineer with MUDA. Now, I'm going to be taking you through something we call the liquidity rail. So the question is, what's the liquidity rail? Now, basically, the liquidity rail is a tool that is supposed to be used by service providers and client wallets to provide liquidity. In context, for example, it's if you find a company a wallet that provides services like utilities, electricity payments, uh, bank account transfers, paying electricity, paying for water, and all that. That way, you're going to find that it holds fiat accounts with all those service providers. For example, if a company is providing bill payments for electricity, you're going to find that the company is going to deposit 10,000 to that company that provides electricity. Then they're going to post another 20,000 to a service provider that provides probably airtime, another 5,000 to a company that provides data. Basically, you find that if you have liquidity of 100,000, you're going to split it into maybe 10, 5, depending on how many providers your wallet supports. Now, with the use of blockchain, you can solve this. The problem with this is you're going to find that if you have fraught with, for example, bill payments for water, where you have like 10,000 and people are using it a lot, it gets depleted, it's done. But then on the company where you have a fraud that pays electricity, you still have maybe 50,000 that is not being used. So you find that the people are paying for water now are not being able to do that. But then you have 50, because you've run out of fraud here, but then you have 50,000 here that is not being used. So with the introduction of blockchain, then what if the 100,000 that you have was in one account, whereby if you need to pay for water, get it from that 100,000. If you need to pay for electricity, get it, so that you don't have to distribute your fraud to everywhere. That's the whole point of liquidity. Right now, in the normal way of how these things would work without the use of blockchain, basically you need settlement because you need to pay a company that pays for your electricity, for water. You send them messages, API requests, they pay someone 100, 200, and then there's a reconciliation process because you're sending messages that are saved in a database. But with the use of blockchain, now messages are going to be used as there's no need for settlement. Because, for example, if I send you one USDC, I don't need to I've sent you one USDC, like one USDC itself has value. So it's different from if I send you an API request that has amount 1000 value USDC, like that's a database entry, it's useless, it's just data in a database. But with blockchain, if I send you a message that has 1000 USDC on a blockchain, then you've received $1,000 basically. So no need for settlement, and the transaction is I send you a message, that message comes with a settlement. So that's what the whole point of liquidity rail. Now that's what we come to solve. Now I'm going to be taking you through the code of such an implementation, and then maybe we can start from there. Now, to start on this, in order for that service to work, you have two providers, or you have to it has two parts. So there is clients. By clients I mean wallets, for example mobile apps that have users who need to pay for bill payments, send money to bank accounts, interact with mobile network operators, and all that. Now those wallets are the ones who hold liquidity in different providers. Then we have another part for providers, for example a mobile network provider, a bank, a utility service provider. Now those are service providers. So the liquidity rail now has something called clients, and then something called providers, service providers. So clients are wallets, web apps. Service providers are utility companies, banks, and mobile network operators. So this was implemented using Python, and it's one code base that interacts with both. So to start with, it has the starting point is the run.py. So when you're starting it, you set up whether as a provider or a client. Now, if you're going to run it as a provider, the whole purpose of a provider, now maybe let me start with the client. Now, with client apps, the whole point of this is we build this one and give you an executable, a binary file that you can put on your server. Then it has an API. It implements an API that you can it implements an API with API. So basically now, for example, on the server of the client, if you want to create an account, if you want to send a payment, there is a JSON API specification. It's something like this. So for you, we provide with you this kind of a JSON API. We provide a JSON API that you can interact with. So basically, because most people don't understand really how blockchain works, so it's easier to just provide someone with an API that interacts to their localhost service. So the moment we give you this service, it's going to be running on your local server, and then for you, you integrate with it through JSON. So for you, what you're going to be doing, for example, this is a request for creating a key pair, just as an example. So we have a pen for getting balance, making a payment, and all that. So basically, on all this, it's more of, for example, making a payment, we put in a recipient, a service ID. Now, the whole point of this is to help client wallets to use the blockchain without actually going through the whole headache of integrating with the blockchain. So we give you something that you're familiar with. Everyone is already familiar with using JSON at least. So we provide you a client, you run it on your server, and then you integrate with it with JSON. We provide you the JSON specification, and then for you, you send requests to that service, and then it broadcasts transactions to the blockchain. So for example, this is a request for sending to a payment to the service. Now, how this would work is you select an amount, and then the recipient sending token. We are using UGX, for example, here, which is an asset that has been created on Ripple. Then you choose a service ID and an account number. Now, the service ID will provide a GitHub open file where you can see the services, and so this is the file. So you see, for example, if I'm going to pay for service ID 1, I know it's MTN Mobile Money, I know the company, the number, I know the chain, and then I can get the address. So this is the address that now the wallet will put in here. So now here, the wallet is going to send 1000 XUGX on the XRP chain to this address. Now, that it's as simple as that, basically. So we are providing you an executable or binary, put it on your server, integrate to it as a client, so that you can interact with the wallet without basically going through the blockchain interactions. So now, on the client side, the moment you send this payment, it's going to be broadcast to the blockchain. Now, on the service provider level, now we have there another option for the service provider. Now, for them, what they do, they have listener. So now, for example, this service provider, for one, they have a listener that is listening for payments that are coming to here. Now, once they get this request, we're going to pass for them a memo field that has the service ID and an account number. So now, this solves two things. One, there's no direct integration between the client and the service provider. So all the client will need to do is broadcast this transaction to the blockchain. Then the service provider will listen for the blockchain, get the service ID. But if they get the service ID as one, they know that they're going to pay for this service. And then they know they're going to pay this account number, period. Done. Once the service provider receives this, get it, confirm the transaction, make a payment out, and then basically now the client can query the transaction status to know if the transaction was completed or not. So basically that it's as simple as that. Now let's start with the client. So like I've said, the client is going to integrate with this using a JSON API, right? So on the client side, when you're running this, you start with something called so basically this is it's the starting file initiating to see how you're going to start the file, and then it's going to go directly into the controller level. So the controller is here. Now this one, as you can see, these are just endpoints. So these are endpoints that are going to be called through the API. So for example, if I start this service as one sec. So if I just start the service like this, it's supposed to start this service as a client. So as you can see, it's starting the liquidity rail. This is the first version, blah blah, and then it starts on this port. So now here basically what you're doing is, now that's the client server. Now the client will have to run this on their local host. So you can just, if you look at this, the bridge URL, just running on localhost port 8001. So for example, if I create this, all I'm doing is just calling this service, then it's going to just generate for me a new key pair in case I need a new key pair, and then it's supposed to display it here. It's the same for get balance, make payment, and all that. So you can, as you can see, it has generated a new key pair here. So basically now on the client level, all they are doing here is just we provide them a service that they can call using JSON, the normal way they do it. So these are all the endpoints that they can call. So if you look at these endpoints, for example, generate key pair, we have an account. So it goes inside the generate key pair. And then, so right now, this service supports XRP and some other EVM chains and Ethereum. So right now, it's running on XRP ledger. So now I have a connector for XRP ledger that defines a number of operations. So for example, if you look at this, I have generating a key pair, create an account, checking balance, getting transaction, path payments. So basically, sometimes you will need to use path payments, for example, if in case we want to accept XRP or USDC directly here so that you can convert it into fiat currency. You have multi-signatures, issuing an asset, send an asset. So if in case, for now we don't have an endpoint to issue assets, but in case we need clients to issue their own assets, send asset, and then this is sending the native XRP, then adding trust lines in case, now for example, when you're starting and then you need to add a trust line to the coins that we load. So basically now this is these are the list of operations that we support on the XRP ledger, and pretty much these cover our whole use case, like I said. So our use case is about sending transactions and providing a JSON-based RPC, JSON-based API service to clients so that we can remove the hard of them integrating with the blockchain, which some almost don't understand. Now, so basically now so I have helpers, and then I have a configuration file that you can look at. It defines everything. It defines, for example, here if you can look at the XRP, I define the URL. I define currently we are using XUGX as the coin. You can define the contract address. But contract address here I'm talking about an issuer basically. So I just wanted to use the same format, but there is an asset code and an asset issuer here. So this one is an asset issuer in this particular case. Now, so basically now the code format is I'm trying to, this uses something called a MVC architecture, where I have controllers, I have models, but then obviously since it's JSON-based service, I don't need views. So I have a number of operations: generating key pairs, checking balance, getting a transaction, and then making transfers and all that. So you can see here, this is an option for making a transfer. You're sending XRP and all that. So basically, this is pretty much the service for the client. This is what the client will need to interact with. By client, I'm talking about client wallets. Then, so when you're providing this to service providers, now, from what you've seen here, if you run this without any parameters, then by default it runs as a client service. Now, if I run this as, for example, let me run it. Python 3 run .py, then I could provide let me see, provider service. Oh, sorry. So now you can see it's the same thing, but if I run it as a service provider now, this one starts an engagement service. So basically now on the client, you can see it's a JSON-based API that listens for incoming transactions. But then on the service provider, it's just an engagement service. So you can see here, I'm just listening for incoming transactions on an account that the service provider sets. You remember in the example I started with, so the client sets their public key that they're going to be receiving payments on. So basically now, the moment they receive those transactions, because these transactions come with a service ID and an account inside a memo. So this is the code for the service provider engagement. It's where is it? Application. Then I have the XRP cron service. So basically now this is the engagement service, API requests. So here I set up the socket provider. So I start with the run, I set up a socket provider. It's set up in the .env file as an environmental variable. So this is the WebSocket. Then I come, I do subscribe to the blockchain events on transaction received. Now on transaction received, I just call my function. I'm just yet to link this one to the saving to the service provider database here yet. But on the transaction received, then I log the transactions that have been received. Then I set up the address. Where is the address? Yeah, it's here. So this is where I set up the address. It's also in my env. So this is where now I'm subscribing to events that are happening on my address. So basically, this whole file is about subscribing to events on an address, and then I listen for those transactions, and then I filter out which ones are coming for UGX, and then once the transaction is received and confirmed, I post it to the service provider DB. So basically that's it. So this is the file for the service provider: listen for incoming transactions and then make payouts. So in short, this is the liquidity rail. I'm sharing the repo for the code. This is the repo. If you can look at the video for the source code, this is the repo where it is. Right now it's on the stage branch. Feel free to take a look at how it works and then play around with it. Thanks. That's it from me. Maybe you can run more tests on it and make a few transactions and see how it works. Thank you.